Thing I want to show you all is a simple exploratory analysis. This is taken directly from the Urban Informatics Toolkit online book, and you'll hopefully have read this by the time you see this video. All right, so this is an R Markdown document, as we kind of went through earlier. And the first thing we want to do is load some packages. Packages are collections of code that help us do things faster. Each package typically contains a series of functions that serve some purpose. And I've created a package for this course that contains some data that's used in the online book. So it's called UITK, short for Urban Informatics Toolkits. So the first thing I want to do is execute this. And this is probably an error you're going to get. It says error in library, there is no package called UITK. This is a super common error that you're going to just see forever and ever. It happens to me all the time. This means you're using a package that you don't actually have installed yet. So if you want to install a package, you usually type install.packages and then the name of the package. Okay, and unfortunately, this package is just hosted online and it isn't in the normal package repository. So we actually need to follow along and do a couple things. We need to install a package called remotes. Remotes helps us install packages from places other than CRAN, which if you remember, the CRAN is the Comprehensive R Archive Network, and that's where all official R packages go to live. This will be there one day, but that's not today. So I've been able to install this package called remotes. You'll see that we've been able to install the package, and it was downloaded to this location. Don't even worry about that. That's just some place on your computer. And I'll actually put this in a code chunk. So I ran install.packages in the remotes, right? I'm going to comment this out because I don't want this to actually be ran by anyone. And also in this code chunk, I can say eval equals false. This means that when we render this R Markdown document, this chunk itself will not be evaluated. It's essentially like commenting out a whole entire code chunk. Now what I want to do is I want to call a single function from the package called remotes. And it's called install_GitHub. This is going to be super confusing at first, but I want you to know that this is saying, hey, look inside of the package called remotes and use the function called install_GitHub. This is called the namespace, and this is the function name. If I loaded, for example, so actually let me just illustrate this for you first. If I run install GitHub and the package lives at Josiah Perry /uitk. If I run this on its own, it's going to say, hey, I can't find this function, install GitHub. That's because the package isn't loaded. The package remotes isn't loaded. And while we have it installed, R doesn't load everything right away. It only loads the things that we tell it to when we need to. What we can do is, there's two ways we can do it. We can go use this approach, where we use the library. But we really only want to use this when we're actually going to be using multiple functions from a package. If we're only going to be using one function from a package once, we want to call it from its namespace, right? And this is how we do it. We type, the namespace is just the name of the package. So we're going to be putting this remotes : in front of the name. So now R says, okay, we're going to be using this function install_GitHub from the package called remotes. So now if I execute it, it's going to work. And it's going to go to my GitHub repository, Josiah Perry /uitk. And if we go to here, we can go to github.com/Josiah Perry /uitk to see where it's actually being installed from. And you can see it's here on GitHub. This is all of the code. And what's happening is that R is going out to the internet, downloading all of the files that are right here, and installing them on your own computer for you. And you can see that this repository, as this is called, contains instructions to install it, and it actually has our course schedule for the readings as well. A lot of these links will only work if you're signed into Canvas, but the names of them are here for us as well. It's going to go through everything. So this is really nice. Now if I go back, It's going to ask me if I want to install all of these packages or update these packages. I'm going to say no, because if you look, these are package versions. So I can see that rlang is the name of the package. It wants to upgrade from 0.49 to 0.410. That difference is very small. So if you see this stuff, know that these package versions, this symbol, this format here, is major version, minor version, patch version. If there's a discrepancy between the major version, that's probably a big deal, and you should upgrade, right? And then it becomes progressively less of a thing. So if this number is changed, the amount of change that's occurred to this package is very, very minimal. If this number is changed, it might be somewhat substantial. So you can see here, CLI, there's might be some significant changes here. But if there's a big difference between this first number and the first number on both of these sides, that's a really good indication that you're very out of date with your code, or sorry, with your packages. It might be time to update. So I'm going to choose none, because I don't want to install everything right now. So now it's going to go ahead and install this package for us, which is perfect. So I'm going to comment this out. And now, if I go down here and run library uitk, that's awesome. It has loaded the package for us. And you can see it says loading data for the Urban Informatics Toolkit. Now, what is actually contained in the package? That's a really good question. How do we figure that out? If you go into this tab here, there is the Packages tab. And this lists every single package that is installed. I've probably got a lot more than you do, just because I install things left and right. But you can search for the name of the package that you're interested in. And you can see that here, okay, it's listed. And I actually refreshed because I installed the package after we started the session. So if I click on the name of the package, it will show us some of the documentation that's in here. That's really nice. And it's only data sets at this time. Perfect. So now I can also load the tidyverse. And if you've done your reading, you'll know that the tidyverse is a collection of packages. And as I said earlier, packages are things, are collections of functions or collections of code that helps us do our job a little bit better. Perfect. So now I've loaded this. And now we can kind of begin doing our simple analysis. What I want to do first is just kind of get an idea of what this data is. So I'm going to, in its own code chunk, right, I'm going to type the name of the object and print it out. So this is what's called a tibble. It is just a table. A table is a two-dimensional object, right? It's 2 dimensions because there's an x and a y coordinate, right? When we were plotting charts back in middle and high school, we would have an x and a y coordinate. The same is true here, right? So it's flat, right? We have, this is our x and this is our y. Our rows right here first. So there's 1,456 rows and 7 columns. Now this view, it's nice for for a lot of people, but what we can actually do too is we can view an object as well. So it will give us a more familiar perspective on that. So the function name is capital VIEW. And then we provide the name of the object that we want to view. In this case, it's ACSEDU. This is short for American Community Survey Education. If you've done the reading, you'll know that the ACS is a survey that is done every year by the U.S. Census Bureau, and this release that we're working with, this data set, was provided by the Boston Area Research Initiative out of Northeastern University. So now let's get an idea of what it actually looks like. And this might feel more comfortable for us. So here we can see that we have column names, med house income, that's the median house income less than HS, so the proportion of individuals living in this census tract with less than a high school education, how many of people here have a high school education, some college, bachelor, and then some demographic information. The proportion of the population that is white, and then the proportion of the population that is black. And we can see that this is one row, so this is one observation. Remember, rows are observations. It's that your unit of analysis. In this case, a row is a census tract. We don't know which census tract, unfortunately, but it is a census tract. And then a column is a variable, right? So in this case, we want to measure median household income for every observation. And if you're not super familiar, a variable is just something that describes a characteristic of the observations. So if your unit of analysis is people and every row is a person, a variable could be something like age, it could be weight, it could be gender identity, it could be favorite food or something, because the columns describe the rows, okay? It's super, super, super important for us to really, really understand. And I'm going to make you read a paper called Tidy Data. It's really informative, and if you can kind of conceptualize that idea of rows are observations and columns are characteristics or variables, we will go so far. It'll really, really help you in your work. Okay, so now what we want to do is we want to use the function called ggplot. ggplot comes from a package called ggplot2. The 2 is because it was the second iteration of the package, and the first one didn't do so well, apparently. But ggplot2 is here to stay. And I really want to go through this plot sequentially so we can understand it. ggplot2, the GG stands for grammar of graphics. So specifically the layered grammar of graphics. So there's a really thorough and thought out methodology to the way that we do this. And if we want to see the documentation for this function, we're going to type a question mark in our console. And here it's going to be question mark ggplot. It's going to load the function documentation that we're going to be looking at. And you can see here, this is where I always start, under usage. How does it look? How are we going to interact with it? Here we can see that the first argument we're going to be working with is the data. And by default, it's null. That means it's nothing. And so what happens if we just provide it with this table that we've loaded from the UITK package? What happens? Okay, that's just gray. Like what is that? This is because we need to, so ggplot now knows what we're going to plot, what object we're going to plot, but what from that object are we going to plot? Are we interested in looking at the variable less than high school grad, some college, bachelor's degree, white, black, what is it? So to tell ggplot what we're going to plot, we need to specify some mappings. These are aesthetic mappings. And by that it means what column are we going to map to an aesthetic? And here the aesthetics are going to be the x-axis, the y-axis, the color, the size. What are we going to visualize? And here you can see the default thing is AES. That's short for aesthetics. So what does that documentation look like? Okay, so the first thing we see here is that we have X and Y. These are important. What's going on the X-axis, and then what is going on the Y-axis, right? So here we're going to provide this AES to the mapping argument. Notice that we didn't actually specify mapping equals, and that's because we're doing this positionally. Since it is the second argument and we're providing the AES in the second position as it's anticipating, we don't have to say this. But if these two things were to swap places, I'd have to say mapping equals AES and then data equals ACS EDU. When we don't specify the name of the argument, R is going to say, okay, it's in the first argument position, because note the comma here, first argument position. So it knows that it's data. All right, so now I'm saying, okay, well, I want to map the x-axis to this variable median household income. So if I run that, what happens? All right, it's a bit better. It's a bit more filled out. We now see that on the x-axis, it's filling in some spots. It's filling in those ticks. It's starting to get an understanding of what we want to plot. But there's nothing there. right? Like what are we going to do with it? So now we need to do what's called adding a layer. In this layered grammar of graphics, we can build on top of the plots that we're creating. And there's tons and tons of different types of geometry. Geometry is what we're going to use to kind of create these plots, or to like determine what is actually going to show up on this chart. And if you kind of go back to the beginning of statistics in your mind, when we're looking at a single variable, we always want to visualize its distribution, right? Like how does it look? And that's called a histogram. We're going to use a histogram to do that. And if you kind of like type geom underscore and wait to see all the things that are pre-populating from RStudio, you'll get to see that there's quite a bit of different geometries that are built into the package that can do all sorts of things. And frankly, I don't even know what all of them do. I know a fair amount, but there's just so many. But if we want to create a histogram, there is something called geom underscore histogram. And you can see I'm adding a layer. And the really key thing I want you to take away is that when we add geometry, we're going to have to press a plus, we're going to have to add a plus sign after the ggplot function. This plus sign indicates to ggplot that we're going to be adding another layer to this graphic that we're creating, right? And in this case, we're adding geom underscore histogram. And I will emphasize that every time you have that plus sign, you should have a new line there. This is for readability, right? Like writing, with good writing, there's good style. And with good programming, there is also good style. And the key thing to that is really just legibility. How well can you or someone else read it? And by using more space, it really helps us understand the flow of the program that you're writing and things like that. And it doesn't get cramped. Right? And I will be grading on that, so just be aware. So now what we're doing is we're adding this histogram there. And now we actually have a plot. That's awesome. That's really awesome. So now we can see the distribution of the median household income, right? And it looks, if you're familiar with your term, your beginning of intro stats, this is a somewhat normal distribution, or it fits to a bell curve. Okay, and it has this median somewhere, or the middle value, right? Is probably somewhere between $50,000 and $100,000. It's about $75,000. And this really helps us understand, like, well, how is income distributed across Boston through the census tracts? Like, this alone is really informative. But one thing I want you to see here is that it's saying bins equals 30. This is saying it's going to create 30 different bars to bucket our values. And we can be, if you increase the number of bins, it shows more granularity to the distribution. So if we reduce the number of bins and say it's something like 15, it's going to do a lot more smoothing to the plot, right? Now we can say there's fewer bins, and I can say there's 7 now, and it becomes more blocky, right? The more bins there are, the more fine grained that we can actually see that the data is. But the goal here is we want to create a summary view. So really do your best to balance the number of bins for sort of smoothing purposes and summary values. I like to choose something around like 15, just because it shows us the distribution pretty well. But again, this really determines on the number of observations in our data set. 30 is totally fine for this case. Just be aware, right? So for example, if I say 300, look how it changes. It becomes really spiky, and it's not as informative in that message of the distribution. So now we can change the x-aesthetic to a different variable of interest. What is the bachelor attainment rate across Boston? Oopsies. It looks rather normal, but really fat, right? And there's a lot of variation here, okay? Now we have an understanding of like these two different variables on their own, but we want to figure out the relationship between the two. The histograms are helpful, but how do they relate to each other? How does the, if I look at here, like how does median household income compare to bachelor attainment rate in a census tract, right? Like how does this value compare to this value and all the way throughout our data set? we want to plot one column against the next. And we're going to create what's called a scatter plot. That is a bivariate visualization. Bivariate meaning two variate variables. And here, now that we're looking at two different variables, we're going to specify an x and a y axes in our aesthetic mappings. And this is super, super helpful for us. And one thing I want you to keep in mind, whatever goes on the y-axis is supposed to be our variable of interest. We want to know the effect of bachelor's attainment rate on the median household income. Okay? So the variable of interest that we're looking for is on the y-axis, and the thing that affects it is on our x-axis. And you can see now that we're actually changing our geometry because we're no longer interested in that histogram. We're interested in a scatter plot. And to do this, we want to add points onto the map for these x and y coordinate pairs. So if I execute this, we get the scatter plot, right? We see a very interesting upward trend. I mean, I think we'd all expect this, that the more educated a neighborhood, the more wealthy they may be, right? This is super helpful. Now, if you're thinking about, like, what is that typical pattern? Because there's a lot of dispersion here, right? A lot of variance. The wider this relationship is, the points are on the plot, the more variation there typically is in the relationship between these two variables. Now, if you're familiar with the idea of linear regression, we can actually add another layer to this plot to show what that linear regression would look like on top of the plot. Now we can see that there is this regression line going right through it. And if you don't know what this is, no big deal, right? You'll have to learn this at a later point in the class, but a linear regression is a type of statistical model that figures out the relationship between two numeric variables. And this is cool because now we're creating a really informative graph that helps us understand this. But you'll see here that the labels for batch and median household income, they're not really, you wouldn't want to share this in like a news article or a publication because like those are kind of underscores. We want to be more clear about it. So what we can do is we can actually add layers, another layer to our plot. Here we're going to be adding a layer called labs. That is short for labels. And the arguments to the labs function is the aesthetics that we're going to be mapping to. So here we can see that we're mapping to the X aesthetic, Y, and title. We haven't specified anything for title yet. But by default, X is set to batch because that's the name of the variable we provided. By default, Y is set to med_house income. And we want to have more informative labels. So we're going to say the first argument is equal to X equals % of population with a bachelor's degree. And I think you may have been starting to get intuition of this, but when I'm using words like here, method equals LM, I put them in quotation marks. This is because these are not objects that we're referring to. They're not columns in a data set that we're referring to. These are just single text values or character values or string values that we're working with here. That's key to remember. Objects, arguments don't have quotes. Single values will have quotes around them. So here we're saying X is equal to this value, Y is equal to this value, and the title is equal to this. So now we can execute this, and we have a much better looking plot. It's really nice. We have well-formed axes labels and a title. And we can take this like one step further, right? Like we're looking at the relationship between bachelor's attainment and median household income. And we can see from this graph that as the bachelor's degree proportion of a population with a bachelor's degree increases, we can see that the median household income increases. But what other things can we actually ask from our data set? What other things are there? And we can see that we have some demographic information. Like, what is the proportion of the population that's white? Is there a relationship there? We can visualize a third dimension here without making it 3 dimensions by mapping to another aesthetic. In this case, we can think about color, right? Like, how can we use color to visualize other things in our variables, in our charts? And here let's map the color argument, the aesthetic color equal to the column white. Um, we're using white because Boston is a very white city, so using something like percent black or percent Asian is really not that informative, unfortunately, because there's such a minority, right? So if we can see the percent of white people, we can understand the complement, which is going to be, I don't know, probably around 10% of other races, so or ethnicities. So here we can add this extra mapping to the aesthetics, and we run it. And then another thing I want to notice here is that I'm actually let's comment this out first. Let's run this now. I've added a subtitle saying colored by whiteness. I've commented out this, or actually let's do this. I will take out this argument for a moment. Okay, let's run this. Now we can see that the more diverse a census tract, the less the median household income. It's unfortunate, but I think we might have all expected that, right? Racism's pervaded Boston for decades, and especially in the 80s, as you may have heard. But one thing we'll notice about this chart is that the points overlap each other. There's so many points, we can't necessarily get a good idea of where all the points are. So what we can do is actually reduce or increase the transparency of these points so that we can see some sort of overlap. And that's what this argument alpha is. It is the transparency. So if I say alpha for the geom underscore point is equal to 1, they are entirely opaque like they are right now. And that's the default. But I can set it to something a little bit different, right? I can say 1/3, so 33%. And now we can see a bit more of this overlap, right? And we can see that this relationship is actually a little bit more clear, but there are some darker places, darker points up further in the higher income distribution, right? So this is a way that we can use ggplot to visualize our data in really informative ways and provide graphics that really asks questions of our data and can be used to communicate the points that we're trying to make. Okay? I hope that was helpful.